There are times when you're going to be required to do a u substitution and a definite integral at the same time. So as a reminder, definite integrals are integrals with numbers on the bounds. This is the example that's going to show us what to do there. So obviously, you can plug this into the calculator and just go math, 9 fnint, and I'll show you how to do that in a second. But first, let me show you how to do it by hand. So the process is very similar to what we did before. We're going to start with let u be, in this case, the base x cubed minus 4. That's going to be my u. So it's pretty much the base that has the exponent. X cubed minus 4 is going to be the u. What would the derivative of u be? That's going to be 3x squared dx. And so one thing to notice is that the 3 in this problem is missing, so I'm going to have to put in a 3 and divide out by a 3 to keep everything balanced. The other thing that I have to do is replace the 0 number and the 2 numbers with brand new numbers. So 0 right here means that x is 0, and the 2 right here means that x is 2. So what do I replace those x's with? Well, according to the problem, the u is supposed to be x cubed minus 4. So if x is supposed to be 0, then what do you get? Well, just negative 4. And if x is 2, the u is supposed to be x cubed minus 4. If x is the number 2, then what do you get in its place? This is 8 minus 4, which is 4 at the end. So my problem becomes 1/3. Instead of 0 and 2, we're going to have the new numbers. Instead of 0, we're going to have negative 4 because that 0 replaces, or the negative 4 rather, replaces the 0 because of what we said there. And we also said that when x is 2, the y is, or the u is going to be 4. So we're going to put a 4 right there in the upper bound. And again, now the 3x squared and the dx together, that's going to be my du. So we're going to grab them all together and write down du there in their place. And then finally, the last thing we have to change is the base, the u. The base in this problem was x cubed minus 4. That gets replaced with the letter u. But keep in mind that the u in this problem had an exponent 5, so we're going to keep the 5. Okay, so that was my chart. Basically, I just have to add an extra couple of lines in my chart to get the numbers out of there, replace them with numbers for u. So this is now 1/3, and the antiderivative for u to the power 5 is going to be u to the power of 6 divided by 6. Instead of writing plus c, I'm going to write the little bar and put negative 4 and positive 4. So this means that what I'm going to do next is going to be something called the fundamental theorem of calculus. So according to the fundamental theorem of calculus, I'm supposed to plug in the upper bound. So plug in the 4 to the power of 6 divided by 6. Then plug in the lower bound, so 1/3 negative 4 to the power of 6 over 6, and subtract the 2. So again, the way it works is the 4 on top gets plugged in into all the u's, and the negative 4 on the bottom gets plugged in into all the u's next, and then we subtract the 2 in the middle. That's what the fundamental theorem of calculus tells me to do. And all this is going to go into the calculator, and it's going to give me some answer. Let's find out what the answer is. Turns out that the answer for this problem is actually a 0, and that's it. So all that work to get a 0, but we didn't know that ahead of time, so we had to actually do the whole thing. So let me kind of bring this to the calculator and show you how it would look like if you were typing this in your calculator screen. So as soon as you turn on your calculator, what you're going to need to put in next is the command for the integral. So that's math, and then option number 9. And we need to type in the expression x squared times x cubed minus 4. So just like I see it on the paper, x squared, parentheses, x cubed minus 4, close the parentheses, and give it the power 5. So that's the end of the expression. Now I got to tell the calculator I'm integrating with respect to x. Then I got to tell the calculator the lower bound followed by the upper bound. And close the parentheses and just hit enter. And there it is. 0 is the solution, which is what we wrote over here. So that's the end of the problem.